One of the things that we're going to have to do with stoichiometry is deal with what we call limiting reactants. And we see that when we have situations in which the reactants that are going to be used in the reaction, we're given the quantities of everything that shows up on the left. So we have to make sure that we're making the smallest amount of product, but we can't just do that by visual inspection sometimes. What we have to do is we have to convert each reactant to the same product to determine which is the smallest amount of the product that we can produce. Once we find the smallest amount of the product that we can produce, that's going to come from the limiting reactant, so that reactant will then be our limiting reactant. The best way to see this is to take and look back at our thermite reaction. And I want to find out what the limiting reactant is if I take 15 grams of aluminum and react that with 15.0 grams of iron 3 oxide. Recall that the equation is Fe2O3 plus 2 aluminums goes to 2 irons plus Al2O3. So we're going to set up our standard stoichiometry in this. We'll start with the grams of aluminum, convert that to moles of aluminum using the molar mass of aluminum, then use stoichiometry to convert from moles of aluminum to moles of iron, and then convert from moles of iron to grams of iron to figure out the amount of iron that we're going to make. So when we do that, the 15.0 grams of aluminum will divide by the 26.98 grams multiplied by 1 mole of aluminum, and it's going to get me into moles of aluminum. Then we'll use our conversion factor. From our equation, there's 2 moles of aluminum makes 2 moles of iron. So 2 moles of iron goes on top, 2 moles of aluminum goes on bottom, and now we've converted to moles of iron. The last step of the conversion is to multiply by the molar mass of iron, which is 55.85 grams of iron divided by 1 mole. When we go through and do this, we're going to end up with 31.1 grams of iron produced. Now, you're going to recall that we've done the next step, converting from grams of iron 3 oxide to grams of iron in one of the previous videos. So let's just look at this one more time. We're going to take the 15.0 grams of iron 3 oxide, divide by the molar mass, which is 159.7 grams per 1 mole. Then we're going to do a 1 to 2 mole conversion. 1 mole of Fe2O3 in the bottom, 2 moles of Fe on top. Finally, we'll multiply by the mass of iron, which is 55.85 grams per 1 mole, and that's going to give us 10.5 grams of iron produced. So to figure out which is the limiting reactant, we need to see what's the smallest amount of iron that we could make. In this particular case, 10.5 grams is less than 31.1 grams, so the Fe2O3, our iron 3 oxide, is going to be our limiting reactant. Let's go ahead and try another example. If I react 2.55 grams of nitrogen and 5.55 grams of hydrogen in the Haber reaction, what is my limiting reactant? Well, we're going to convert grams of N2 to grams of NH3, and then we're going to convert grams of H2 to grams of NH3. So let's look at the grams of N2 to grams of ammonia. Alright, take 2.55 grams of N2, and we're going to multiply by 1 mole of N2 divided by 28.02 grams of N2, which is the molar mass of N2. Then we're going to use stoichiometry to convert from moles of N2 to moles of NH3, and for every mole of N2, it takes 2 moles of NH3. So 2 moles of NH3 goes on top, 1 mole of N2 goes on the bottom. Last thing we got to do is convert from moles of NH3 to grams of NH3, and that's going to be multiplying by 17.03 grams of NH3 per 1 mole of NH3. we end up making 3.10 grams of NH3 from the 2.55 grams of N2. Next, let's go ahead and look at the hydrogen. 5.55 grams of H2. We're going to divide by the molar mass, which is 2.016 grams of H2 per 1 mole of H2. Then we're going to use our coefficients to convert from moles of H2 to moles of NH3. And that's going to be 3 moles of H2 on the bottom and 2 moles of NH3 on top. Finally, we'll use the molar mass of ammonia to convert from moles to grams. So 17.03 grams of ammonia on top divided by 1 mole of ammonia on the bottom. When I type this into my calculator, I'm going to get 31.3 grams of NH3. Well, 31.3 grams of NH3 is about 10 times more than 3.10 grams of NH3. So the 2.55 grams of NH2 is going to produce the smallest amount of NH3. Therefore, my N2 is going to be my limiting reactant. Finally, I'm going to give you one more problem to practice, and we'll bring this to class to figure out. Take 15.25 grams of C2H6O and react it with 10.25 grams of O2. What is going to be the limiting reactant using the equation below? So make sure you find the product. Doesn't matter if you find CO2 or H2O, but you need to make sure you find the mass of the same product. Good luck.